Hey guys, my name is Brian Bosley. I'm the CEO and founder at PHIBER Systems up in St. Augustine, Florida. And I'm down here at Merritt Boat Works in Pompano Beach, Florida. We just installed a PHIBER system on Captain Carl Anderson's yellowfin. He's got twin Merc 225s, and it's a beautiful installation. Let's take a look back and see how it went. So we're unpacking the PHIBER system components now, and in order to do a true push-button flush, there's a couple requisites. Push button implies no garden hose, and no garden hose implies you got to get water from somewhere, and in this case it's going to be from the vessel's tank. So in order for us to actually pull water from the vessel's tank, you've got a seawater system in these engines and you've got a freshwater system here. You've got to put a barrier device in between the two. And what we've invented and is currently patent pending is something called a hydrostatic lock. And the way it works is it uses simple physics to trap water between 2 points. And when water gets trapped between 2 points, it's hard to compress and you can't stretch it. Basically, it becomes a barrier, a gate inside the system. So this is a hydrostatic lock that I'm putting together here right now. It consists of a special electronic solenoid valve with a specific type of plunger and a ball check, a specific type of check that's unique to this system, and what we call a locking chamber, which is where the water actually becomes locked and trapped, and therefore the barrier between the boat's freshwater systems and seawater systems downstream. So once the hydrostatic lock is in place, then you need to distribute the water, in this case to twin engines. So at PHIBER, we've been working on flow engineering for quite some time, and we've come up with a couple of very industry unique components that focus on distribution of water without any loss. And so for a multi-engine configuration, this is what we call a flow hub, and it's designed so that as water moves into the system, it creates a pressure wall and it distributes out to multiple engines evenly. So you can flush up the quads with this little octagonal block because of the way the inside has been machined and the way it operates. It's just simple physics, and you'll probably hear me say that quite a bit because I love simple physics. All right, so in this case we're only using a twin engine system, so we're not going to use a flow hub. We're just going to use a stainless steel Y with 2 hose barbs that will feed the hoses that we installed into the engines. This will just get installed to the very end of the hydrostatic lock, and there's your freshwater flush manifold. So the next component we're going to discuss is the PHIBER control module. In order to do a flush between a boat's freshwater system and a raw water or seawater system, you have to have a brain. This brain ensures all of the safety circuits that are required to tie the freshwater and the seawater systems together are in fact engaged before a freshwater flush can occur. So the freshwater flush control module, it's actually a very simple device. It's got a simple in and out connection where the harness goes. This gets wired into the vessel's existing network. You've got some programming buttons on the top, a manual flush button on the bottom, a USB software update port, and finally your digital screen and an SD card. The SD card actually tracks all of the flush data that occurs on this particular boat, or more specifically with these 2 engines. So flushing, every single run cycle that occurs is clocked inside of here, and then every single flush cycle, which should be in proximity to the run cycle, will also be clocked. The data is stored and encrypted and is available only for download using the OEM manufacturer's software for the engines on which they're installed. So with Mercury, you're going to have a Mercury decoder If you have a Yamaha, you're gonna have a Yamaha decoder, a Honda, and so forth. And that will prove compliance with manufacturers' recommendations for routine maintenance and freshwater flushing. All right, I mentioned the networking cable that comes out of the control module. Well, this is what we call a junction module. Now this right here is actually where all of your safety circuits, your power circuits, your switching circuits, pump relays, everything would get networked into this little box. So we're going to install this box in the back. We're going to tie all the vessel's native electrical circuits to this, the ones that are relevant for the freshwater flush. And then we're going to tie all the control modules circuits to this box, and this becomes your interface. Okay, with every single system, you get one of these label kits. And these label kits are, as a boater, I hate not knowing what things are for, whether it be a valve or a switch or a wire. So we give you these label kits so that you can actually go and install labels on anything the PHIBER system touches inside your boat. You get electrical, you get mechanical, you get engines, sea keepers, you get anything the PHIBER system is going to touch, you can put a label on it to keep track of the system function. And lastly, you get a freshwater flush engagement switch. So this switch is installed typically at the helm, maybe near the engine controls. And it comes with switch plates, both horizontal and vertical. And the way this works is you push the button, it engages the programming that is put into this at the point of installation, and the flush function engages. And you can use this to engage the manual function or the auto functions within the control module. So we need to feed this freshwater flush hose from where the manifold is going to be installed in the back here, through the firewall, engine wall, and out to the engines to connect to the engine's native freshwater flushing circuit. So I'm going to try to push this through the back, right into the rigging bundle. So this is your rigging bundle here, where all of your engine controls go through from the boat into the engine. And we're just going to snake this freshwater hose up and through it. Ha! All right, now it's starting to move. All right, so we pulled this through the rigging tube. Now we need to look for a hole in the gasket to make sure that we can push this in to the engine. And there is a cutout already in there for what looks to be a cable that is currently not employed. So since it's unemployed, we're going to give it purpose. All right, Karina, your job is to pull on that while I'm pushing on the other end. We want to basically bring it all the way around the back side of the motor. Okay, let's see how much you got there. All right, I think that might be enough. We're putting the freshwater flush hose for the PHIBER system across the front of the motor down below, where this is going to come up and connect into the native freshwater flush circuit. So we've now pulled our freshwater flush hose through, and this is the Mercury native flushing port, and this hose comes from this fitting and goes up into the engine to freshwater flush it. So the problem with this particular engine's freshwater flushing hose is that it's kinked, and you can see how it's kinked from sitting in its native position. The hose has to make a really hard bend and go around the engine. So what we're going to do is we're going to cut it right here and put in a plumbing T, and we're going to attach our freshwater flush hose to the T. So now you have two ways to flush the motor. You've got the PHIBER flush, and this right here remains fully functional in its intended configuration. We're going to cut it right at the damaged area. And then this will be installed like such inside the engine so that the PHIBER flush flows through and doesn't have to make a hard bend to get to the engines. It's all about flow engineering.
look at that. Like butter. What we've done is we've taken the fiber system and run it through the T, and we've taken the native flush connection port and tied it to the remaining barb. And now we're just going to tighten it up, and it is done. We can put the cowling back on. There we go. All right, so now the next step in this process is to pull some wires between the helm station and where the control mechanisms are going to be installed, which is in the rear. So we're going to pull what's called a DC sense trigger wire. We're going to pull a power wire, and we're going to pull the wire that goes to the button at the helm, the freshwater flush engagement button. So this is all going to get strung in. I'm going to go in here. We've got a handy dandy string that somebody left. All right, well, somebody's gonna have fun unwrapping this on the other end, but if it pulls through in one shot, it'll be worth it. Okay, so we just pulled 3 wires through from the helm back here to the aft locker where the fiber system will be installed. So we have a power wire which goes to our 12-volt system to provide power for the control module and the flush mechanisms. This wire right here is DC sense. Now, in order to flush an outboard engine, you need to flush it when it's off. So this will be tied to the engine's ignition circuit somewhere up at the helm so that the system knows when the engine is off and it's okay to flush. And then the third conduit is got wires for the freshwater flush engagement button. So there's a button that goes in at the helm, it's a momentary switch, and when it's pressed, it will signal the programming inside the control module to engage. And that's what controls the flush for this particular boat. Mil-spec connector is on the side of the control module. Done. And I'm going to go ahead and pre-wire this in advance of going into the boat so that I can just basically set a bunch of screws and then make the connections inside the boat. So all we're going to do is bring the wire around, and the control module is going to be beneath the junction module. So we're going to trim this to fit, and we're going to start connecting up all of our signal wires. So we're using pipe dope, which is both a sealant and a lubricant to assemble the hydrostatic lock. These are always sold as kits and never completed systems because we want to give the operator, installer, the freedom to install the system in the way that makes the most sense for the boat, because every boat has a unique fingerprint and personality profile. So when you get a fiber system, it's comprised of kits that have to be installed in the way that makes the most sense. Hydrostatic lock is now constructed. All right, so we know the engine is plumbed for 3/8 twin engines. So we're going to put a 3/8 barb on the end of this hydrostatic lock. The inlet from the freshwater pump on the boat is a 1/2 inch. So we'll be putting a 1/2 inch barb on the upstream side of the hydrostatic lock. So we installed the freshwater flush controls right here at the helm station, right where the command center is at, so it makes it convenient. As soon as you get to the dock, get the engine in the position you want, push the button, and the PHIBER control system will do the rest.